Hello friends, today we have to study the important properties of soil mechanism. Important properties like color, texture, structure, consistency, shrink-swell potential, bulk density, porosity, permeability, infiltration, drainage, depth, available water holding capacity, reaction cation exchange capacity, landscape position. Soil color useful tool for providing information about the other soil properties like organic matter content, soil minerals, seasonal, high water tables. Organic matter content, soil minerals, seasonal high water tables like high, low. Useful properties for providing the information about the other soil properties like organic matter, soil minerals, seasonal high water tables. Red color due to hematite, iron. Organic matter contain soil minerals, seasonal high water tables. One-shell color chart used to identify the soil color. This chart allows soil scientists to uniformly describe soil color in the field. Soil scientists compare the color found in the soil with the color chips found in the chart. Redoximorphic features soil colors formed by the repeated chemical oxidations and reductions of iron and manganese compound resulting from saturation. Useful for predicting the presence and the depth of seasonal high water tables in the soil. Depletion low chroma gray zones from which iron and the manganese oxide or a combinations of iron, manganese oxide and the clay have been removed. These zones are identifications of the chemicals reductions of iron resulting from saturations. Nodules, concretions, soft masses, pore linings, and the other features resulting from the accumulations of iron, manganese oxide, and indications of chemicals reductions and oxidations resulting from the saturations. Reduce matrix, low chroma, low chroma horizons from which most iron oxide have been removed by leaching. These horizons are indications of the chemicals reductions uh, iron from the long-term saturation. Textures, the relative proportion of sand, silt, and clay particles in the masses of soil, like the comparisons of particle size grains scales used by the soil scientist USDLI gravel, sand, silt, clay, unified gravel, sand, silt, or clay, ASU, gravel or stone, sand, silt, clay. These are the chart for finding out the grain size in millimeters. Texture triangular used by soil scientists to define the basic structural classes. Field soil scientists frequently estimate the texture by feel using their hands. These are the texture triangle percentage clay, percentage silt, percentage sand. There are the values from 0 to 100 like 10, 20, 13, 14, 15, 16, 17, 18 and 19 to 100. For the more exact measurement, there are the laboratory techniques that can determine the exact amount of soil, silt, and clay. These are the also soil texture by the field flow chart. Triangular texture. Soil containing the large amount of sand exhibits a little plasticity and cannot retain the large amount of water or nutrients. They have the large void between the particles and can readily transport water and air. Texture. The properties of silt are intermediate between the sand and the clay. A silty soil can retain the large amount of water but tend to have the moderately slow permeabilities. Soil high silt can present the problems for the engineers since they will shift under the stress and slide and the flow when the wet. Clay exerts a great influence on the soil chemicals and the physical properties. Clay particles are chemically active and the proportion of clay-sized particles greatly influence soil physical properties, including the aggregation, porosity, water movement, and the storage, aeration, and workability of the soil. Structure: the arrangement of the primary soil particles into the compound particles or aggregate. The type and the grade of the structures plays an important role in the movement of water within the soil. There are eight structural types commonly recognized in the soil profiles, like granular, single grain, blocky, prismatic, columnar, platy, wedge, and massive. Some of the examples of the soil structures, like the granular, blocky, platy, prismatic, columnar, and wedge structure. Granular, rounded aggregates usually less than 1 by 4 inches in diameter. These rounded complexes lie loosely on the sand surface are readily shaken apart. The aggregates are called granulates and the pattern is called granular. This is the most common type of structures found in topsoil. Single grain. Each individual soil particle is separate and there is essential no structures. This is only in very sandy soil and is a type of structures commonly seen in sand or dunes at the beach. Structures blocky. The original aggregates have been reduced the blocky irregular phased and the basically equal in height, width and depth. Blocky the structures is the most common type of structure seen in the subsoil. The horizon in North Carolina. Prismatic, characterized by the vertical oriented aggregates or pillars with the flat tops. These elongated columns vary in the length with a different soil. Prismatic structures is commonly seen in soil with a high clay content and the horizons are dominated by the high shrink-swell clays. Columnar, categorized by vertical oriented aggregates or pillars with rounded tops. These elongated columns with flat tops vary in length with different soil, most commonly seen in soil that have a high sodium content in dry climate. Plating. The aggregates are arranged in the thin horizontal plates or sheet. This structure is commonly found in the soil layers that have been compacted. Platy structures inhibits the downward movement of the waters. Phage. The aggregates resembles phage thinner at one and thicker on other. This structure is seen in soil with a high clay content that is dominated by expensive clays such as Mont Monolite 2:1 clays. Structures affected permeability by the influencing the path by which water can flow through the soil. The type of structure determines the number of interconnected macropores which radially permit downward movement of water. There are the some figure for like that the single grain blocky plenty, granular prismatic massive like the rapid, moderate and slow. Consistence, the degree and the kind of cohesion and adhesion that a soil exhibits and the resistance of soil to deformation or rupture under applied stress. Field evaluation of consistence usually include a rupture resistance, stiffness and plasticity. Rupture resistance is a measure of the soil ability to withstand the applied stress. For this test, most soil is normally used. A natural occurring soil aggregate is placed between the thumb and index finger. Pressure is slowly applied to estimate the amount of force that is required to rupture a soil aggregate. Stiffness is the capacity of soil to adhere to other objects. Stiffness is estimated at the moisture content that displays the greatest adherence when the pressed between the thumb and forefinger. This normally occurs when the soil is quite wet. There are the figure for the percentage of cases non-sticky, slightly to or moderate sticky, very sticky, like clay, silt clay, sandy clay, silt clay loam, sandy clay loam, silt loam, sandy loam, loamy sand and sand. Plasticity. Plasticity is the degree to which a reworked soil can be permanently deformed without rupturing. Plasticity is evaluated by forming a roll wire of soil that can is 4 centimeter long. Percentage of cases non-plastic, moderate plastic, slightly plastic, very plastic. Shrink-swell potential. Shrink-swell potential is the measurement of amount of the volume change that can occur when a soil wets and dries. Most of this volume change is due to the clay fraction of the soil. Clay swell when the wet and the shrink when dry. Soil high Soil high 2:1 clay such as montmorillonite tend to have the high shrink swell potential. Soil high in 1:1 clay such as kyanite tend to have the low shrink swell potential. A soil with a high shrink swell potential can cause severe problems when used for urban development unless the problem is recognized and the proper engineering precaution taken. Shrinkage swelling can buckle roads, cracks, building foundation and walls, even damage plant roots. Bulk density. Bulk density is the masses of dry soil per unit volume, including the air space. Bulk density has major effects on movement of soil, air, and water in soil. Soil with high bulk densities are often compacted. Soil compaction restricts rooting depth, which reduces the uptake of water and nutrients by plants. There are the two figures like the no compaction and compaction flow pan. Compaction also decreasing infiltration, thereby increasing runoff and the hazards of water erosion. Permeability. Permeability refers to the movement of the air and water within the soil. Permeability rate is the rate at which a saturated soil transmits water, usually expressed in inches per hour. Texture, structure, bulk density, and the type and the connectivity of macroporous influences permeability. Hydraulic conductivity is a measurement of the movement of the water that can move downward through a unit area of unsaturated soil in a unit of time. Saturated hydraulic conductivity KSAT is a measurement of the amount of water that can move downward through a unit area of saturated soil in a unit of time. Infiltration. Infiltration is the downward entry of water into the immediate surface of soil and is influenced by texture, structure, bulk density, and the type of conductivity of macroporous. Soil with a high infiltration rate are resistant to erosion because there is a little runoff. Drainage. Drainage refers to the frequency and the duration of the periods of saturation or partial saturation. Internal soil drainage is important because of its effects on land use and management decision. Drainage. The apparent water table is a type of saturation in which all the horizons between the upper boundary of saturation and a depth of 6 feet are saturated. Apparent water tables are the frequently encountered in a low-lying areas where the slope of the land is insufficient to provide the good drainage, such as flood plains, depression, and the nearly level areas. Apparent water table, unsaturated, saturated. Seasonal high water table or drainage. A purged water table is a water table in a soil in which saturated layers are underlain by one or more unsaturated layers within 6 feet of the surface, often caused by a restrictive layer that has slow or very slow permeability. Common in soils that have clay subsoil and poor structure. Purged water table, unsaturated, aquatic, saturated, unsaturated, seasonal high water table. Drainage. The depth to soil water tables fluctuates throughout the year. Most of this is due to rainfall variability and seasonal change in the rate of evapotranspiration. In North Carolina, the highest water tables are normally encountered in with the winter and early spring months. Available water holding capacity. The capacity of soils to hold water available for the use by the most plants. It is commonly defined as the difference between the amount of soil water at field capacity and the amount and building point. There are the figures for the increasing in textile heaviness. A field capacity available water inches water per foot of soil. Depth. The usable depth of the soil is an amount of consideration when evaluating a soil for a particular land use. Groundwater can be easily impacted in soil with a shallow depth to rock. Root restrictive layers are many permanent zones in the soil. The restricts the growth of plants' roots. Bedrock is the most common root restrictive layer. Reaction. The reaction is the measure of the acidity or alkalinity of a soil. Acidity or alkalinity is determined by the amount of hydrogen and hydraulics ions in the soil. When the hydrogen ions outnumber hydrolysis ions, the soil is acidic. In the reserve conditions, the soil is basic. A pH scale is used to measure the level of acidity or alkalinity. There are the scale for environmental effects, pH value, and the examples like the acidic, natural, basic. See the scales where the water have the which type of nature. Reaction. In the NC, the natural soil pH will range from the 4.0 to 8.0, with the most soil tending to be acidic with pH values of 4.5 to 6.0. In order to optimizing plant growth, farmers and the homeowners commonly adjust to pH of a soil by adding soil. The amount of lime that needs to be added should be determined by the soil test. Cation exchange capacity. Cation exchange capacity CEC is a measure of the soil ability of a soil to hold and exchange the cations. It is one of the most important chemical properties in soil and is usually closely related to the soil fertility. A few of the plant's nutrients, cations that are the part of CEC, including the calcium, magnesium, potassium, and ammonium. Landscape position, hill, hill slope position in PDP, two-dimensional descriptors of the part of line segment. Back slope, this is the best applied to transect or point not areas. Positions code, landscape positions, geomorphic component, a three-dimensional description of the part learned from the micro features that are the best applied to areas. Thank you. If you like the video, please subscribe my channel, Sarma IS Academy.